Hi there, welcome to this learning series on Amazon Web Services or AWS or simply Amazon Cloud. We are going to learn all the AWS services and products and would also learn how we can deploy and develop a vast range of applications that includes IoT application, web application, Android application, or simply a storage device or data warehousing or complex ERP solutions. We can build a vast range of applications and we will learn here with practical demonstration and would create sample projects um, in each category. We will learn about each of the services or products one by one in depth. So let's start. So these are some of the vendors, most popular vendors, the General Electronics, Expedia, TCL, Ubisoft, Vodafone, Adobe, Samsung. These involve or employ the use of Amazon Web Services and rely on AWS Cloud. So AWS has evolved over a rapid pace of innovation from year 2006 or 6, 7, 8 with simple 24 applications or Amazon Elastic Cloud Compute or EC2 with Elastic Block Storage, and now it has evolved to a huge range of services and products in multiple categories like compute, database, analytics, IoT. Even it has a game engine. It has an AR and VR support, augmented reality and virtual reality support for innovation and development. There are various competitors in the market for AWS that includes IBM's Bluemix, Microsoft Azure, and Google Cloud. But AWS is ranked first among all those cloud vendors in various terms. In terms of market capture, AWS has over 34% of the cloud share. It is simple to simple developers or basic developers, or it is very vast for complex or advanced developers. It has a very interactive environment and simple to deploy applications. So these are the services. These are various services that we can use to empower our application and create a huge range of applications. It has analytics, mobile development, app development, enterprise app, hybrid cloud management tools. It has a marketplace where we can develop and sell our code even to our fellow developers or any other developers. We can work in a team and host a DevOps process toolchain. Here we get a technical support from AWS, as well as AWS also provides us learning content, and AWS certification is most prestigious IT certification to do. Everyone is almost everyone is seeking an AWS certification if he or she related to cloud computing. It is a very reliable and ever growing platform. AWS has an infrastructure services and it has very secured environment. So why we need a cloud? Actually, cloud is used to scale our project. You might have an idea what a cloud computing is. If you have to develop an entire infrastructure, either you host a website or a complex ERP solution. If you have to store them on a physical bare metal server in your data center right in your office, you need some staff workers to manage them, and a huge amount of salary and electricity bills and networking bills has to be paid to them. And if your data has to be scaled up, you need more racks and racks in your data center. It would be hard to every time control that thing. For getting rid of those things, we shifted to cloud. Amazon hosts all the infrastructure, networking, and other parts, and we have to deploy our application and get involved to use the services. As you can see here, these are the few services of Amazon Web Services. These are the facilities and tools that we can use from all the categories: compute, storage, content delivery, database networking, developer tools, management tool, analytics, mobile services like Cognito, which is very popular these days, enterprise applications, and other applications. We can employ them, and we need as a developer or cloud architect or a developer, we have to grasp all the key terms involved here, and which we are going to do, and learn each of them one by one in a better and slow and steady pace. And we are going to master these things at the end of the course. We will cover all the theoretical part and build a practical solution. So this image was of a dashboard, AWS services dashboard, that was previously available, but now it looks like this. A range of product has increased. As you can see in earlier image, there are only 4 services in the compute category: EC2, EC2 Container Services, Elastic Beanstalk, and Lambda. But now it has 6 services: EC2 Lightsail, which is a new service, Elastic Container Service Lambda, and Batch, which is a new service, and other services. Similarly, there has increased services in each category, either be machine learning, analytics, or other things. Database and storage services be the same. In analytics, we get a new service that is QuickSight, Athena. We have AWS Deep Lens, the Pinpoint, and other services. So we will learn each of them later. So thanks for now. Welcome friends. So now we are going to create our own AWS account, Amazon Web Services account, which is vital for exploring all the AWS services and deploying anything using AWS. So just search on Google or any search engine the AWS free tier account, or simply go to aws.amazon.com/free. Now on the top right, just hit the create an AWS account button. Here you will be redirected to a link where you can create an account. Just simply provide all the information required. First, there appears an email ID. Just provide an email ID. Create check that I am a new user. Then hit the sign up button. Enter your name. If you are an individual, you can create an individual account. If you are a company or an organization, you can create your organization's account. It is very simple. Just re-enter your email ID, your credentials, your password, and retype the password again. Then hit the create button. Create account. Then your contact information is required, your address, your country. I'm just providing some garbage value, anything, because I've already created an account. So this is an example for a company or organization. You can select from any country, example India. Just provide the address information and other informations. Address, city, state, postal code, phone number, and other informations right here. For example, anything. Enter the captcha and now just provide your payment information, the debit card number or credit card number, name on your card. It is very important step. Actually, you are not charged any amount until you select any services that are not covered in your free account. Just provide all the informations and click the verify button. Then there will be OTP, one time password requirement for your related to your connected with your mobile phone number with your bank account. When it is verified, a token amount is debited from your account, for example 2 rupees or 4 cent or any such amount. It will be returned back by the Amazon later on. Then enter the OTP. When it is verified, you can move to further steps. Identity verification. Here you need to provide your phone number, a mobile number, along with the country code, and AWS. There you will receive a call from AWS, and you need to enter the PIN which is provided to you. After completing this step, you can move further. It may take some time for verification, but not much time. When your identification is completed, you can move to your dashboard. You can select whether you are a basic developer or a student or business, anything. Just select from them. I'm just selecting basic. Then click continue. So this is your account created, and you can move to dashboard. Sign into your account, enter your username and password. The username is typically your email ID and password, and then you can access your dashboard and all the AWS services thereby. So this is a home page. These are all the services, and this is your account. Hope this works. If you find any error, you can call tech. Hi friend, welcome to Amazon Lambda. Here we are going to learn what is Amazon Lambda or serverless computing, or in other words, function as a service. We will explore what Lambda is and how we can build complex applications based on Amazon Lambda. Amazon Lambda runs code in response to events that are triggered based on certain conditions. So what is an Lambda? Just for a theoretical understanding, Lambda runs stateless request-driven code called Lambda functions. If you are an experienced programmer or you have learned some of the concepts of Java, Python, Node, or other languages, you might have come across Lambda functions. In Java 8, it supports Lambda function, but in Java 7, it does not support Lambda. In Python 3, it supports Lambda functions. Lambda functions are stateless functions that does not depends on objects. It automatically calls. It is request driven code and it can work on clusters. It does not need to be processed on a single processor. So it is an in-depth study. You can define AWS Lambda functions based on either of these three languages, Node.js, Java, and Python. The Lambda functions are triggered by events that can be state transition from one state to other state based on other AWS services that may include kinesis, streaming analysis, pipeline, Cognito, and other services. You only need to pay for the request serve and the computation time. You don't need to pay for an isolated task or for hosting your entire process. When a request is made or served and the computation is required, you need to only pay for that certain time period. With Lambda, you can focus on business logic, not on the lying under infrastructure. You just you get focused to your code and you just improve your code. Does not care about lying infrastructure that is done by the AWS and other services. That is the benefit of this function as a service. For example, if you have to develop your Android application or web application in a traditional manner without using the function as serverless computing, you need to deploy everything, run from the entire application on your own. But with Lambda, you just create a single task. It is automatically interrelated or get involved, integrated with other services of that same app. For example, push notification. For if you are creating a push notification, you does not need to create the notification service within the app. That is outside the app, and you don't need to worry about the app and its code. Similarly, this is Lambda. You just upload your code on AWS Lambda, and it handles everything. AWS handles capacity, scaling of your app or other thing, resources, the deployment, which is most important thing. You don't need to manually deploy everything. It is fault tolerant. It can handle various kinds of faults on its own. It has a monitoring facility and it maintains log. It is a web service front end and have security patching. So how this works in an event driven compute manner. So AWS Lambda comes with two fundamental components, that is Lambda API, as you can see in the center, and Lambda containers. So how they work with a trigger or invoke function request. When an invoke function request is made, you can see on the left hand side of the screen. When an invoke function request is made, it invokes a request or generates a request to the Lambda API that creates a reuse container and passes it to function A that resides in the Lambda container, the function that you define based on Lambda API. The function processes the result and returns it to Lambda API. The Lambda generates the response code, the response thing, anything with that is response. So you see that deployment is on the case of Lambda API, and your code resides within the Lambda container in form of a function. So how it works? For more example, you just need to upload your code to AWS Lambda. That could be mobile, AWS services, or other endpoints. Set up your code to trigger from other AWS services, HTTP endpoints, or in-app activities like in-app purchase and other things. Lambda runs your code only when triggered, using only the compute resources needed. When it is not triggered, you don't need to pay anything. If it is triggered, you pay for that resource. You just pay for the compute time you use, not for the idle time. So how does it work in a more enhanced manner with web application? For here you can see Lambda is integrated with other solutions. For example, API Gateway, S3 storage on AWS Cloud, and the Forge, and it integrates with the web application. Suppose a web application makes a request to upload, make a S3 upload request URL. It passes to a request to upload some content to the S3 cloud, S3 storage. It goes to the API gateway, which in return triggers the Lambda function. The Lambda functions return S3 upload URL, the link where you can upload. The link is passed by the API gateway to the web application. The web application then upload a model or content to S3 storage, which triggers a Lambda function to identify that the file is uploaded. The Lambda functions then upload model from S3 to Forge and request translating moves ahead. After it is done, the web application checks the translating status, whether it has been uploaded or not. It goes to the API gateway. API gateway passes that trigger and translating request and trigger the Lambda function. The Lambda function in return returns the translating status, and which is reflected back to the web application. So this is a simple way how it could work with the API gateway, S3 and web application. Similarly, we can involve it Lambda with a wide range of services and applications to provide a huge range of solutions on various scenarios. Let's see some previous stats about the usage of serverless computing frameworks or facilities provided by different cloud vendors. As you can see, AWS Lambda is far ahead from other services. Almost 77% of the users of the FaaS, function as a service or serverless computing, prefer AWS Lambda, and they would prefer in the future too. Although they would like to try some new platforms like Apache OpenWhisk that runs over IBM Bluemix Cloud, the Google Cloud Foundation, the Azure Functions, Serverless Framework, OpenFaaS, and other things. But AWS Lambda is far ahead among them. So you can trust AWS. It is updated regularly. Let's take some examples. For example, if we are willing to build a weather application, how we can do so? For example, in our weather application, we need to be notified by the weather. We first need to create an S3 bucket for front-end code for weather app hosted in S3. For example, our weather app is hosted on S3. The data and the code resides in the S3 bucket, the object storage on AWS Cloud, where our application uses clicks to link to get local weather information, where a user of our website or app can click to get the information of local weather information. It passes its request to API gateway as in the previous case. The API gateway makes REST API call to the endpoint. App makes the REST API to the endpoint, which in return generates a Lambda. Lambda function is triggered, which is a Lambda code run to retrieve the local weather information kept in the DynamoDB or other database and returns data back to the user in the similar fashion. So this was the application of weather application. Similarly, we can create an image thumbnail. How it is done? For example, we have taken a photograph. We then upload our photograph to the S3 bucket. Then when our upload is done, a Lambda event is triggered. When Lambda is triggered, our Lambda code for resizing the image based on web, mobile or tablet size or thumbnail creation is generated. We just need to write the code to resize the image. That is the Lambda code, which resides within the Lambda container, works with the Lambda API that automatically get deployed with everything else. One other example is analysis of streaming social media data. We can use Kinesis for big data analysis of social media data. The Kinesis gets the social media streams loaded into Kinesis in real time. The social media content from Facebook, uh, LinkedIn, Twitter, and various other sites get loaded. You just need to write the logic within the Lambda function, and when the data is loaded with the Kinesis, the Lambda is triggered. The Lambda function is called. The Lambda code returns code that generates hashtag trend data and stores it into the DynamoDB. You may define the certain hashtag trend. For example, if you want to analyze a single hashtag, for example, hashtag Trump for president, or then you can fetch all the information what people are saying based on this hashtag, and all the information that is analyzed by the Kinesis is kept to the DynamoDB for further analysis. The social media trend data immediately available for the business under the query. When it is stored in the DynamoDB, you can make queries and build a complex solution and analyze the trends very easily, very swiftly, and it has a very large scaling capability, so you does not fear to um, of scaling thing. So that's for now. We will explore more things later and do a practical demonstration. Keep loading, keep moving ahead. So now we are going to deploy a serverless microservice with AWS Lambda, which is used for serverless development. So this is a Lambda dashboard. We can create functions right here. Um, the functions can be independent from applications and they get deployed very easily and rapidly without any delay. Just hit the function option and here we can create a function. For example, we have created a function, the hello world of Python runtime. If you want to create a function, you can create from scratch. You choose from blueprints and add serverless application repository on AWS. Use the existing ones from the given below based on your requirement for fast track and quick deployment. For example, I have selected the Firehouse CloudWatch log processor based on Kinesis. This should be analytics one. This is the source on GitHub, and simply we can deploy it by clicking the deploy button below. So it is showing an error. We need to initialize the bucket name. We have not created a bucket. It must show an error again. We have to create an S3 bucket for storing our data, and when it is stored, it will be created. So this is created. We can create another app or test this app. So this is the function. the AWS Lambda Hello World based on Python. We can add qualifiers and actions. We can export function and perform other operations like testing, configure test or other test based on events. We can add triggers that could trigger our event like API gateway, AWS IoT, Amazon Manager, manage Amazon API gateway. We can just code our function right here using inline code editor based on any programming language from the given list. For example, C Sharp, Python, Node, Go, other languages. And we can edit it right here. We can add tags. We can execute role. We can define the size in megabytes. We can also define the timeout, the time to run this Lambda script. We can add various triggers from here. CloudWatch, for example, it is being added to our application, the Lambda application. We can create a DynamoDB for database. We can delete it. Similarly, we can add more thing. Hit the test button. It will test the corresponding key value pair. Just enter the name of an event, whatever you like to do. Hit the create button. You can also go to CloudFormation console. Here it is showing the status complete. You can get a complete log of these events that occurred. You can go to source code and modify it according to your project. AWS Serverless application model and other stuffs. You can add services from here or remove triggers, S3 or other things. Hi there, we are learning AWS Lambda, and now we in this part we are going to explore how AWS Lambda works internally. We are going to learn handler functions, various objects, and other thing that you are required to build a proper serverless scripting language, scripting. So for understanding Lambda, we need to first explore what is trigger. So in this scenario, there are three types of input, three cases. We have developed three Lambda scripts. On the left hand side, the input is called trigger. The service which invokes certain kinds of input, that is called trigger. It could be Amazon S3, API gateway, RDS, DynamoDB, or any other AWS service. We can set trigger for that. In the first case, we have developed a Lambda script that takes an input and stores that input value in a certain format to DynamoDB. We can do so. In second case, we have a website where we have various users and we want our users to upload their profile photos. As the number of users for our website is very large, then it could be millions or billions, the size of a photo they uploaded could be very large, and thus increasing our cost and space required. We need to write a serverless script separate from the website backend or front-end logic. We want it to keep separate from other scripts. That's why we are using Lambda, and we want just to compress that image. So when a user uploads an image of large size to Amazon S3 bucket based on his profile photo, he does not know actually what is S3, but he simply clicks the upload button, which is get uploaded to S3 based on JavaScript. And when this operation is performed, it could be set as triggered with AWS Lambda, we can set. And when it is set, an image is uploaded, the AWS Lambda script for this file keeps the image short and stores back to S3. In the next case, we have an API gateway which exposes the code functionality to take inputs and perform various operations. In this API gateway, uh, we may take input values like A, B, or any types of values that could be textual, image, video, or other kinds of value using certain scripts like JavaScript or C# script or any other script. When that program is run and input a variable value is passed through API gateway that is triggered, which pass that values to Lambda script, certain Lambda handler script, which may perform operations like addition, like A plus B, and other operations, and store back this information to any kind of database or any place of requirement. So these were the simple case where we can see how Lambda works. We can keep writing various Lambda scripts and uh, store them in AWS cloud. We can write different scripts, different files. We can write using zip file or directly. We can write our scripts in any programming language of our choice. Not always available, like Node.js, Python, Java, Ruby. These are available, and other languages. We can write our Lambda scripts, which have handler and various objects. So how it works internally? When a request is made to the AWS cloud for a Lambda script, a trigger is generated. Our Lambda script uh, is stored in a container which is being called. It works in the pay-as-you-go philosophy. When the request is number of scripts is less, and the number of containers is also low. When the number of requests increases, the AWS automatically creates more containers to handle more requests. When the number of requests is even larger, the number of containers get larger. It is elastic, it can scale up or down. When the number of number of requests again goes down, we can it automatically reduces the number of containers. It is very useful uh, when we don't want to pay for a large number of requests. Suppose in our website our traffic is very low at certain point of time, and at a certain different point of time it is very large. We would like it to be optimized so that our cost and the resource consumptions goes down. So AWS handles it for us very significantly. We will learn other things later, so keep learning and keep moving ahead. Now we are going to learn handler function for AWS Lambda. So what is handler function? For AWS Lambda function, handler function is the entry point. It is called when a Lambda function is invoked. It is the first function to be run. It is similar to main function in C, C++, and other languages like Java. It is the first function which is invoked. It handles the request or input request. It handles the input. It uses certain objects like callback, context, object. You need to provide a file name and name of the function in the Lambda configuration for this handler function. A handler function is exported so that it is visible to outside trigger the function, the way it is invoked. And there could be a large number of functions, Lambda functions, having different handler functions as well. And handler defines what type of request is to be fetched. Each handler function is invoked based on different inputs. For example, an image upload on S3 could be an event that invokes a handler function. Another trigger or event would be like API gateway request. It could trigger another handler function named B, so on. So how it looks like, it is of the format file name dot exported function name. So here our function name is handler. So we write handler for exported function name, and the file name could be exports, for example here. The file in which we are writing is index.js or JavaScript file. We can write similarly in Node, Python, Java, and other languages. It has three variables or objects, arguments, the event, context, and callback that helps to perform various operations, including log, callback, and operation will based on trigger. So this is how our code may look like in the AWS Lambda dashboard. We have created a Lambda function, and here in the code inline editor we have this type of syntax code. The exports.handler equals to the name of the three objects, event, context, callback, and you can provide a callback function declaration and console.log statement. We will explore each of them later. We have learned handler function and how Lambda functions works internally, and now we are going to explore three objects one by one. Here we are going to learn about event object, that is first object for the Lambda handler function. So what is an event object? Event object is the first object where data that is transferred from trigger to Lambda function get stored. The data is stored with event object. The data that is transferred to Lambda function is stored to event object along with the details. Data could be like if you upload an image to S3 bucket or any file, the metadata about that file storage could be stored with event object. If you are storing with API gateway, the API related information, all the RESTful API or other thing that get stored in the JSON format. And if you are using any database like DynamoDB or Amazon RDS, the data regarding the row insertion or column insertion or updation for any table, that gets stored with event object. So as you can see here, this is the basic syntax for a handler function. Exports.handler equals to function, event, context, callback. Event, context, and callback are the three objects associated with the handler function that helps Lambda perform. Everything which is generated from trigger get stored with event. Suppose if an information is passed to an event object like this. If we are using an API gateway for fetching some information in the form of variables, here this is the form of input. It is a GET request from an IP assigned to a location associated with a query string which passes information like name of a person, location that is equals to Bangalore, year 2019. This information get passed to the AWS Lambda function, and the event object's role is to store data. It is stored in this format. It is a JSON format. It may look like this. It has a path variable, the headers, the accepted, the application type, that is JSON, the path parameters, request context variable, the account ID, HTTP method that is used, the query string parameters, like location is Bangalore. It is very short. It's a compressed form of the JSON data that is stored as an event object. It is a metadata for any file uploaded in Amazon S3 or other kinds of storage, and it could be for any kinds of trigger. This is syntax for the API gateway corresponding to the previously displayed the query string. We have, but there is a huge documentation about this information that is stored in event object. These are not just a few parameters. Um, there are a large number of parameters. This is the link following the complete documentation about API gateway with setup with a Lambda integration. So we are going to say it. This is the page. This is the link. Here it is the complete guideline to this API gateway, and going downwards, this is the format of the information that is stored in JSON format. For example, in this page, with this JSON script, the input is set to the event parameter of the Lambda function as this. The message displays a hello statement. The input could be from proxy, path, assist, the method that is used to fetch the information, the post, get, or any other. The headers, the accept, catch. As you can see here, it uses CloudFront service, so it stores the information regarding CloudFront. It uses the header name, postman, token, host, forward port. It uses the Cognito identity pool for mobile authentication, so it uses this thing as well. API ID. It could go very long. So this is the information. Keep learning, keep moving. We will learn all the Lambda related functions, Lambda components of the Lambda functions one by one, and build a Lambda based solution. We have learned handler function for AWS Lambda function, and we have also learned the event object. And now we are going to learn in this video about the context object. So what is context object? It provides runtime information of the Lambda function, like function name, version, and other informations. It provides you detail about the execution environment as well, like memory limit and other constraints. It provides some information, some properties and methods as well that can be used for coding Lambda function in either of the languages, like Python, Ruby, Node, JavaScript, Java, and other languages. So event object was the earlier object that is called firstly when information from a trigger has to be stored, and the context object provides the runtime information like logs. It brings the log details, and then there will be callback object that we are going to learn later. So as you can see here, there are some properties and methods for this context object. Using this context object, we can check function name, check function version, get invoked for function ARN. As we know that a single AWS Lambda function can have a various versions like version 1, version 2, version 3, 4.5, and so on. We can check dependency based on a certain version. Similarly, we can each Lambda function has a separate Amazon resource name or ARN that can be invoked using context.invoke function ARN method or property. We can check memory limit in MBs. We can check AWS request ID. We can find log group name or log stream name. Similarly, there is a method. There are various methods actually, but one of them is most useful. It is to find remaining time in milliseconds for timeout. Uh, as you know, in Lambda AWS cloud, everything is charged on the pay-as-you-go method. The running time makes the cost. The time duration for which your Lambda function is to be executed and run, you will be charged based on that time. So we have to set a timeout. For example, if a certain trigger is done and a Lambda function is not responding within a given time frame, then we must terminate the Lambda function and set a timeout. If we don't set a timeout and wait for infinite time or a very long time, you will be heavily paid for unuseful unuseful process. So we have to set the timeout to be as low as possible, and we can get remaining time in millisecond using the context. So this is a simple script that we write on Lambda function. It begins with export.myhandler handler function. You could write any name. Pass three objects: event, context, and callback. The context object uh, is associated with console.log, as you can see in this third line, fourth line. We can set log values, the information, and run a callback. So when you run this thing, it generates a success hello from Lambda that was passed using to the console to the callback method, and it brings various log output. As here we can set timeout and memory limit. It shows the log details, the memory limit like 128 MB, function name hello world, log group name, log stream name, remaining time in millisecond, and other information that could be useful to us. We can set configuration for this, for example runtime, the handler name, the role and description. The context object could be used for identifying the remaining time in milliseconds by writing it in a format console.log in brackets context that get remaining time in millis. It will return the time that is remaining to be run, the waiting time. So this was context object. We can build a huge solution using this fundamental and simple looking object. There are a long range of parameters, properties, and methods available. Go through the documentation and we are going to build a good solution. Later we are going to learn about callback objects in next video. So keep learning and keep moving ahead. We are learning about AWS Lambda. We have learned handler function, event object, context object, and now we're moving ahead with learning about callback function or callback parameter. So what is a callback parameter or callback object? You can call it object because it is placed as an object in the handler function. It is a parameter for a handler and it is used as a function. So anything is valid. Uh, where event object was the first object to get started with after trigger. Then comes context object, and as it proceeds, the callback parameter or object is the exit point of your Lambda function. A callback parameter returns something. Callback parameter in handler function is optional. It is not compulsory as event and context. If you do not set callback, then it means callback is called without any parameter. A callback is generated by the Lambda itself when you don't pass any value. So a callback parameter function has two parameters, first parameter and second parameter, and it could be written in two ways. The first way for error, when you are interested in passing an error, just provide one parameter, which would be an error parameter without any null value in the callback method. If you want to pass a success value, then you must pass in a format where null is placed as the first parameter and object value, the success result, is placed as the second variable, second argument. This is a method to pass callback. These are four types of callback uses of callback parameter in ways that we can use to print result, error, or simple information. When you do not write explicitly any parameter or argument in the callback function, it indicates the success without any information returned to the caller. It does not return any information. When you place null in the callback method or function, it indicates the success, but no information is returned to the caller, as above. When you place null as first argument and success as second argument, or any value for the success, it indicates the success with information returned to the caller, the information that you pass as the second argument. When you write error in the callback method, it indicates the error information returned to the caller. So this was the syntax. Now a brief demonstration how it works. As we can see here, if we don't write any callback method, the execution result prints success and returns null. No value is returned. Then when we write an error message, it throws an error message. The execution results are shows the failed result and prints the string that is passed as an error message via callback. And when we set two arguments, the response argument, it displays the response argument and prints success. For this, we have created a variable and assigned values, key value pairs, and want to print that response. So it shows the entire code on the log string. Similarly, when we want to print error message as a response variable, as any variable name, it will show us the result, the failed result, the error log, and the message is termed as the object type object. So this is the callback parameter, and we have learned about the three objects, the event, context, and callback, and now we can implement a simple solution. You must try give a headshot to Lambda function, create a Lambda function, use these three objects within the handler method, and write a simple Lambda function for a wide range of triggers like S3, RDS, DynamoDB, API gateway, and so on. It is not very difficult, but a practice makes the man perfect. Here it fits best. So we need to write Lambda functions, and later we will learn different applications that we can develop using serverless computing with AWS Lambda. So till then, keep learning and keep moving ahead. Hello friend, welcome back. Now we are going to learn about logs with AWS Lambda. So let's start. So logs play a very vital role in hosting a cloud application. It could be either front end, back end, Android application, or any kind of application you build with AWS Lambda or any other environment. You would sometimes need to look through logs. So what are logs? For those who don't know, uh, logs are error statements that error or any kind of a statement that maintains a history of events that occur throughout the running of the program. When a program is running, it may record certain events within the log and maintains a log history. For example, a log in a server environment could be called as a person who has logged into the system using certain credentials, the username and password, and what person was logged into the session when the server has crashed. This is quite a little different. Here we need to generate certain events. For example, a certain section of our code did not run sufficiently or efficiently within a given time frame or any other constraint. We could print certain statements, or that could be error statement or some information within the log that is not displayed to the end user, but it's available to the developer or anyone who is within the testing team or development team. They could go through the logs and read what error may had occurred, and they could fix them later. So this was the log, and in AWS there is a service dedicated to log, that is AWS CloudWatch. CloudWatch automatically maintains or generates the log details where we can check or see what are the logs available. So on AWS, we just simply need to create log statement. We will learn later in this video that we can generate using AWS Lambda function, and that could be visible within the AWS CloudWatch with full detail. Here comes the two things within the CloudWatch. The first thing is log group name, and the other thing is log stream name. As you can see here, a log group consists of different log streams. It could be a class for, you can say a group is a group of persons sitting in a certain class, and a stream is a single person in that group. There could be various streams based on different cloud Lambda functions, or based on time constraints, and group is the combined form of that. We can obviously create multiple groups and multiple streams. A Lambda functions uses this CloudWatch. We can identify log group name and log stream names using certain code. As you can see here, context.log group name, it will print or display log group name, and similarly we can display with a context.log stream name the stream name of log. In Lambda, node.js log can be written using console.log, console.info, console.warn, console.error. You can print console.log to you can write console.log in Lambda function to provide any information statement, or using .info. .warn could be an alert, and .error is error. It may look similar, but are certainly different based on the view. So how it could be written? This is a simple Lambda function code. As you can see here, we have previously written and learned about a handler function, event, context, and callback. There we used the console.log statement. So this is that same thing, console.log. You can use console.log, console.info, console.error, and other. So that to print the our response or our information or error on the log that is visible to the developers. So this is the way that we can write it. When we run that Lambda function, any Lambda function, this is the execution result that is printed just below the coding interface. And here it is the thing that is printed, executed. And here is a blue color link called logs within the brackets logs. By clicking on this thing, something like this would appear on your screen. This is the CloudWatch service page. Here we have different streams of data that we have learned, different log streams classified under a single group. You can create log group or log stream right here, or you can search for any stream or any group right here. It is based on timestamp or event or time. Different streams are generated. By clicking on any one of them, you would get the streams. So putting on any one, the latest one based on the current timestamp, we see the logs statement that we have passed through the Lambda function that run within the console.log statement. Lambda is working fine. We have written that thing in the demonstrated code, and it is displayed in the CloudWatch. The interface for AWS may differ from time to time, but the overall concept would remain the same. The CloudWatch, the Lambda function, everything, the options and the tools. It will not change, but although it could be upgraded. So this was a simple demonstration of creation of logs. Logs could be useful, but not a compulsory thing. It is an optional. If you want to generate logs, it is not a difficult thing. The CloudWatch can be simply monitored or tempered. You can use this service throughout with integration of other services as well. We will learn all other services and options to create Lambda functions. So keep learning, keep moving ahead. Friends, we are learning AWS Lambda functions, and here we are going to learn another method to write Lambda functions. We have learned that we can write Lambda function right on the inline editor provided on AWS Cloud. But there is another method, that is we can write Lambda functions right in our computer, the PC, tablet, or a smartphone, and you can create a zip file and directly upload on AWS Cloud, and there you can deploy it. So how we can do this, we are going to learn it in this video. So on AWS Lambda service portal dashboard, you can find these options where you write the code, the Lambda function code. You get three options. You can write code on inline editor, that means write on your dashboard online. You can upload a zip file from your PC containing Lambda scripts in any language of supported, like Python, Node.js, Java, and other languages. And there is a third method, that is upload a file from Amazon S3. You can upload your content, text files or program files, and directly use that file from S3 bucket with Lambda function code. Uploading via zip or S3 is useful when you have a lot of Lambda scripts, like above 100 files or more than 100 files. or a large number of files. That makes it handy to manage. Otherwise, you have to write each time each script on the editor. But if you have a less number of scripts, you can go with inline editor. So this is a simple Lambda code that you can write and simply create. For example, this is Node script. So save it with any file name .js JavaScript. It will be useful. And create a zip file and you can upload it right from here. This is the option. If you select upload a zip file, the option changes from inline editor mode to the upload button, and you can upload files up to 10 MB size, or if the size is more than 10 MB, upload it first to S3 bucket, then from there you can choose for to upload with from S3. We have created a zip file named app.zip and simply upload it. It will be uploaded. Then the next thing you have to do is to create a role for a handler function using IAM ID. You can choose from existing role, create a new role from template, or create a custom role. So this was three methods. We have learned the three methods. The way we can write Lambda functions using inline editor, zip code, or from S3 bucket. So you could scale your application development from up to one file to thousands of files maybe. So friends, we have learned about AWS dashboard and its interface, various services, and now we are going to learn about AWS command line interface. The command line interface for Amazon Web Services is very useful when you would like to run remote commands for your scaling of projects. When you have less number of projects, less files with you, you can directly configure or upload or perform various operations rightly from the dashboard. When number of resources and files increase drastically to hundreds or thousands, you may need to manage simply using CLI, command line interface, that works remotely from your pure personal computer PC. You can automate various processes using various commands. So here we are going to learn how we can install AWS CLI and work remotely. The steps involved for this process is we need to first install AWS CLI. Then we need to create user in Amazon identity and access management. Then we need to configure AWS CLI using credentials for IAM. So let's go to first step, download and install AWS CLI. Move to your search engine, just type download AWS CLI. The first or second link, move to first or second link. Here we can download AWS CLI for Windows 64-bit or 32-bit, or for Mac and Linux. But for Mac and Linux we need Python and pip to be pre-installed. They installed these two tools, and then you can install AWS CLI. So I am a Windows user and my computer is 64-bit, so I would like to click here. As I have already downloaded and installed this, yeah, I would not go with it. You could download it, and it is a simple process, not very difficult. When it is installed, just hit the next button and agree. It will be installed very simply. Just move to command prompt or terminal in Linux and just simply type AWS. When it is installed, things may look like this: AWS help and other commands that can be run here. So this was simple. There is no separate command line interface for AWS. It gets embedded on your operating system's command line utility or Linux shell. It is simple. Next, will learn to create IAM users and configure the credentials. Let's log into your AWS account and move to the dashboard. We have logged in. Move to the service panel, and from service, move to security, identity, and compliance category and hit the IAM button. Here we can create, this is a dashboard for identity and access management. Here we can manage everything. Just move to users on the left hand side of your dashboard. We need to hit the add user button and create a new user. Just provide a name for the user, for example HS-AWS could do better for me. Provide access type programmatic access, as we need to work on various APIs, CLI and SDK. Create a group. We need to create a group and provide the permission for your resource. For example, if you are creating this account for Lambda, you could provide the permission for Lambda. Just write Lambda and select the particular role that you would need for this thing. You can also select multiple options. I would select AWS Lambda full access for right now and provide a group name. If you don't provide, it will show error. Just provide a name. I would provide a similar name as the user. You may provide anything. Create the group. The group is being created. It is here. You can see attached policy and full details by moving to this link. So this is the permissions, the Amazon resource name, ARN, and other services for various AWS services like CloudFormation and other thing. You can see here attached entities, policy versions, access advisors, and other things. Next, we need to, you can copy permissions from here and change, but I don't need to do this right here. Move towards downwards of the page and hit the next button, review. Hit the create user button. The user will be created. So this is the user, this is the access key ID and secret access key. We would need these things. You need to keep this secret. For configuration, it is important. I will later delete this thing so you could not use it. Just move to your command line interface and write the AWS command to check whether it is working or not. It is working. Let me do some adjustment. Just type AWS config for configuration. So this may show various options for which you can use for config. But for configuration, we need to type configuration, not config. So I did a mistake. You can move above and read various statements that are printed. Now we need to type AWS space configuration, AWS configure. It would ask you access key ID. This is the access key ID. Copy it from here. Enter. Provide the secret access key. It is unique per IAM user. Choose the default region. As I have no region selected, you can check it from your dashboard right here. Just move to above on the taskbar, and here you can see global. IAM does not require any region to be selected. So just type none, NONE, uh, then it is okay. Your AWS command line is configured. If you want to reconfigure it, you can configure it later. As friends, we have learned about AWS command line interface. In the previous video, we have installed AWS command line interface and configured using identity and access management from AWS services. And here we are diving deeper into AWS command reference, all the available commands for Amazon command line interface for every services. So just type on Google AWS CLI command reference or any other thing. So this is the page, document page that opens up. Move to table of content, and here you can see all the services of Amazon Cloud displayed in blue color, be it API Gateway, Athena, auto scaling, Cloud9, CloudFront, Cloud Search, CloudTrail, CloudWatch. Just open it in new tab or in the same tab. You will get the full reference for each service command reference for each service. DynamoDB, Elastic Beanstalk, Events, Firehose, Glacier, Glue, Greengrass, and various services. Because AWS has a huge range of services, and it is difficult to remember all the commands for each services. So it is always being updated, and we don't need to remember anything. Just move to documentation, and here you get. So these are the commands for CloudWatch. Delete alarm, describe alarm. We can select any command and read the synopsis, how it is written. So the anything which is not enclosed in a square bracket is compulsory, and rest all the fields that are enclosed in a square bracket are optional. You could either provide the optional fields or do not provide the optional fields. This is the list for commands for AWS Lambda for serverless computing. We can add permission, create alias, create event source mapping, create function, delete alias, delete function, and perform various operations remotely. If we have a huge range of Lambda services, we would prefer the command line interface over the normal GUI mode. So this is the syntax for creating a function using AWS Lambda on command line interface. So this is the mandatory field to provide function name, and within values we need to provide the name of the function that we are defining. A runtime, we have to provide runtime for the language interface, for example Node 4.3, role, the IAM role, the handler function, that is the main function for Lambda, and all the fields are optional. You can read all the documentation and betterly understand what each category or refers to. Just moving into detail how it is written completely. So this is the page. Here the first thing we need to write the AWS command, that is the first command. Then we need to write the name of the service that we are using. For example, here we are using Lambda service, so we need to write Lambda. If we are using CloudWatch or Mobile Hub or any other service, we need to write the service name, then the action, the particular command, for example create function. Then we need to provide function name, runtime, role, handler, timeout, zip file, and region. As Lambda services are basically regionless, so we can, if you want to leave this part, you just do not write that thing. We could type it on command line interface using the very own CLI mode of the operating system, like Windows command prompt or Linux shell. Just type the AWS command to check whether it is working or not. We have done this in the previous video. We have configured using IAM role. So it is working. AWS command is being accepted, and then we can write this AWS Lambda create function action. So it must ask us to provide the configuration files, because I have deleted that configuration file earlier. Yeah, so it may ask you to provide configurations. So we can configure using AWS configure as earlier video, and then we can write anything here. You could save those files using zip or upload on S3 bucket. So now we shall start with storage. We would explore what is the storage category or options in Amazon Cloud, the AWS. The storage AWS storage options are scalable object options, inexpensive archive storage, or warehouse, persistent block storage, or turnkey gateway solutions. There are three types of fundamental storage options available, that is file storage, object storage, and vault, or you may say warehouse. So we would explore each category one by one. Uh, the first thing is there Amazon S3. S3 is simple storage service. Short for simple storage service is called S3. It is a object storage. You can store anything from 1 byte of data to 5 terabyte in size. It is scalable. You can scale the store anything up to 5 terabyte of size. That means a single file of 5 terabyte size can be stored. But it does not restrict you to store the amount of data. You can store trillions of terabyte of data if you can produce or hold. Obviously you would have to pay for the storage amount, but at some scale it is free, or when you scale up you may get a discount also by Amazon Cloud. It is scalable. You can scale up data anytime or scale down anytime. Its performance is very good. The server has very less down time, up to 99.99999% durability, that it is uptime or running time of the server. Your data is always available. It has infrequent access options. You do not need to frequently log in or everything else. Amazon EC buckets and objects, you can visualize them like a file system, but they are actually stored in a bucket category via an object name. You would get a domain name for your bucket that would be of type bucket name dot amazonaws.com slash object name. It is very simple. You can access this link or your bucket data information anywhere, anytime from any resource. If you want to integrate your solutions, like building a website, if you want to store your image data or any other kind of data on Amazon Cloud, you can do so. If you are integrating it with other solutions available on cloud like IBM Bluemix or Microsoft Azure or Google Cloud, you can do so. S3 is easily integratable with any other options. You can host a static content for a website right here. Just provide your file hierarchy, the www folder, or all the resources files, the image files, HTML files, CSS files, and other files, and just log in via your page name .html. That is simple. You can host a website right from here. but it would not be dynamic like PHP or any server-side script would not run. You need a software specific. For that, you can go to other services. So Amazon S3 provides storage through web service interfaces, that is REST, SOAP, and BitTorrent, currently available of these three. Amazon S3 is reportedly to store more than 2 trillion objects of various vendors, individuals, and a huge chunk of companies. Corporate data are stored in Amazon Cloud. S3 uses include web hosting, image hosting, and storage for backup systems. Amazon S3 guarantees 99.9% monthly uptime service level agreement. You get an agreement from Amazon that they guarantee you your data would be uptime, never down, always available at 99.9% of times. It also provides options to host static websites with index document support and error document support by default. You get the index document or error document. You can define index file or error file. If you're not a web developer, you can still uh, store your huge chunk of data like you do with Google Drives or other thing, but it has no limit whatever amount of data, and it is surely encrypted. No one else without authentication could access your data. So we can build a better solution with Amazon S3. We would explore other options, storage options, in coming videos. So keep learning, keep moving ahead. So here is another storage option on Amazon Cloud, that is Amazon Glacier. Glacier is an archive storage in the cloud, or simply saying data warehouse service for cloud. You can store your data, the data that is considered to be for cold vault or something which is less frequently accessed. For example, a website data is usually accessed frequently in a day, throughout a day, every day, in the month, year, but some kind of storage information is less accessed, and you won't be willing to pay the frequency amount, as S3 is expensive than Glacier. So simply, if you have some data which is not accessed very frequently, and you won't be willing to pay the cost for S3 or other kind of storage, you can move your data to Glacier. Especially when you have a large chunk of data. So it is an archive storage and backup. It is secure and durable. The durability is obviously 99.99%. Your data, when your data does not have frequently access, that data is considered to be for cold vault or Glacier. The retrieval time is up to 3 to 5 hours. The cost of storage is extremely low, $0.01 per GB per month, or $120 per terabyte a year. Whatever feels suitable to you, you may pay that amount. This is how Amazon Glacier works or interacts with other kind of storage. For example, if you have a storage data on your traditional server and you want to shift your appliance or your enterprise software or data to the cloud, how you can do that? On traditional server, you first instantiate an AWS storage gateway service and move your data via storage service to AWS Direct Connect or AWS Import Export to Amazon S3, then and create in the bucket. When the data is uploaded on the bucket, S3 bucket, then you can transfer that storage to Amazon Glacier. Similarly, when you want to download any information file from Amazon Glacier to your traditional server, you can do the reverse process. First move from Amazon Glacier to S3 in the form of bucket, then with AWS import export or direct connect, you can pass through AWS Storage Gateway Service to traditional database. It may work with other services. The Glacier can be integrated with other solutions as well. You can design your own solution with using multiple AWS services available also with other cloud vendors, or simply if you does not develop a complex solution, you can keep your data safe online. Here comes another option for storage on Amazon cloud, that is EBS, or elastic block storage. It is a form of block storage and which is very scalable, that means elastic. Elastic block storage is persistent storage for EC2, Elastic Compute Cloud. It is reliable, automatically replicated within its availability zone. When you store your data using block storage, you don't need to care about its backup. It is automatically replicated and your data is safe. For example, any data center burns out or any disaster, natural calamity breaks out, your data is still is safe. It is secure, it is encrypted, is scalable. The performance depends upon the volume type you define. We will learn in next slide. The snapshot to S3, easy backup. You can snapshot an entire S3 storage or easily create a backup for block storage. The volume types, the block storage volume types come in two major category. One is magnetic, then other is provisioned IOPS. It depends on your use. For example, if you have less money to pay and you can handle latency or need infrequent data access, you can go with magnetic type of storage. The cost is comparatively low, very low, as compared to provisioned IOPS, up to 5 cents per GB per month. The performance is up to 100 IOPS on average. The ability to burst into hundreds of IOPS. Or if you have a very important consideration, a business product that would have a business impact over customers or have a better solution, you can go with provisioned IOPS. That is comparatively faster than magnetic alternative, but it is costly. Consistently performs at provision level up to 4000 IOPS maximum at maximum, which is 40 times more than magnetic kind of volume. It is SSD backed. It is stored on solid state drives, so it is faster than the previous one. It is input output intensive. If your product needs a very frequent input output operations like read write performance or other kind of thing, similar thing, it is better to use with provisioned IOPS. It supports relational databases and NoSQL databases. Elastic block storage has features. You can mount EBS as drives and format as required. It is similar to your Windows drive like E or F drive, or your Linux based. You can mount your block storage drives, the format as you require, simply as you do with your desktop. It has flexible size, the volumes from 1 GB to 1 terabyte in size. It is secure. private to your instances, not available to everyone else. It is available replicated within availability zone, which is very large. The backups of volumes can be snapshotted for a point of time store to restore. It can be snapshot to Amazon S3. You can monitor detailed metrics captured by a CloudWatch. You can obviously involve other services. The CloudWatch is one of them, used for monitoring service. Here comes other storage option on Amazon Cloud, that is EFS or Elastic File System. It is similar to file system that your computer have in your desktop, or be it Linux file system or Windows file system or Mac file system you are familiar with. Here you can arrange your data in formats of files and folders, and you can create or visualize multiple instances at the same time using your admin login. An administrator interacts with EFS through its file system interface. You are the administrator, or if you can appoint other person, you can do so. EFS provides elastic storage capacity that scales to accommodate workloads that run on elastic compute cloud instances and access files through application programming interface or API request. You can run multiple EC2 instances and access files through API request. AWS automatically deploys and manages infrastructure for EFS. EFS is your file system that is distributed across an unconstrained number of servers to avoid performance bottlenecks. You can create your own file system, define your own formats, manage in folders and other content. It is easily manageable as compared to object storage, or if you say other kind of storage. You might be familiar with this thing. EFS is designed to be highly available and durable for thousands of EC2 instances that are connected to the service. EFS stores each file system object in multiple availability zones, so it has a good backup. An IT professional can access each file system from different zones in the region it is located. If we are working in a team and some common files are to be extracted or used by multiple developers in your team, they can do so by directly accessing to the files stored in their availability zones. The service also supports periodic backups from on-premise storage services to EFS for disaster recovery. So this is how our EFS dashboard looks like when you are to create elastic file system. This is the dashboard. You get three kinds of services here: the create service, access service and manage service. Just hit the create file system button and your service is created. We can create EFS service, access them using NFS version 4 protocol, or any number of EC2 instance can work with your file system. You get a huge documentation and support from Amazon service, or you can manage them via EFS console or CLI or SDK via API connect or API calls via other services. Here comes another feather in the flock, that is Amazon Storage Gateway. A storage gateway provides the solution to integrate or transfer your data from traditional databases from a traditional storage to cloud or other storage gateways. It integrates on-premise IT environments with cloud storage. It is your ramp to AWS Cloud Storage. It is the first point where your data from local storage arrives to the cloud via an storage appliance using a secure connection to S3 bucket, then to other solutions that could be block storage or file storage. You can back up your Amazon S3 in a reverse manner. You can archive your Amazon Glacier data. You can frequently access data on premises using ISCSI based block storage. You can, when you want to retrieve your data from S3 or other kind of storage on cloud to your local storage, you can also use this service. How it works: it integrates with files, volumes, tapes to Amazon S3, Glacier, or block storage. AWS Storage Gateway lies in between them. You can uh, integrate Amazon CloudWatch to manage your logs or your resources. You can use CloudTrail. You can log in via IAM, Identity and Access Management, or apply key management service for encrypting or logging your data. You can enable using standard storage protocols to access AWS storage services. How does AWS Storage Gateway works? For example, on customer premise, if you want to upload your data on cloud or shift your data to cloud, the first stage is to move to storage gateway appliance, which is which will be physically connected to direct connect on the internet, and which is stored on storage gateway backend uh, to S3, Glacier, or EBS. We have explored storage options and how they work. We can build complex solutions using storage or any simple kind of storage, because storage is the fundamental of all kinds of information. You cannot create an application without storing any files. So it is a fundamental thing. Next, we will learn databases and other services on AWS Cloud. Till then, keep learning and keep moving ahead. Welcome back, friend. We have done with introduction and we have learned what Amazon Web Services is and what we can do with Amazon Web Services. So now we are going to explore each services one by one. In this part, we are going to start with compute category. The first one to be on in compute category is Amazon Elastic Compute Cloud, or Amazon EC2 in short. It has virtual servers in the Amazon cloud. So what is Amazon Cloud EC2? It has virtual servers hosted in the Amazon cloud that can scale up or down quickly as needed, which is the meaning of elastic. And it has a computational capability, so we can perform all computational cost. It is familiar with existing operating systems, Linux, Mac, or Windows, and you need to pay for what you use. We don't need to pay for hosting our application as we have to do with traditional hosting solutions. EC2 is easy to use. You have the root access control. Root access control means you have the permission to execute, read and write all the services, everything. You are the admin and you have to control your data, your everything from a remote location, while your application or your data is kept on a data center in any region of the Amazon cloud you choose. That could be US East, Virginia, or Indian Mumbai or China or any other regions. It is you have access to use console and APIs. You have access over mobile. It is elastic. That means it automatically scales servers up or down based on your data, your content, or your code. If your requirement is high, suddenly if it grows high, your server can automatically grows up, the elastic expand, or if your requirement goes down, it automatically compress. It simplifies the operations, it improves resiliency. You can run applications securely without any fear of hacking attack or other thing. The physical security is uh, the worry of um, AWS data center employees, and they are heavily guarded. Believe me, nothing can harm your data. If any natural calamity or terrorist attack or anything occurs on your data center, it is all automatically replicated over any other region. That is called sharding. You can run applications globally. You can choose from content delivery network CDN that makes a copy of your content closer to the region where it is actually used or in demand. For example, if you have a website and it is hosted in the USA East region, for example, and your audience are basically from China, then the CDN content delivery network automatically makes the copy of that thing using elastic cache in a nearby region of China. So it will provide your access, website access, or to load faster than it has to be loaded from USA. It reduces the cost and everything. You can easily build highly available applications or use multiple availability zones. Uh, it uses elastic load balancing solutions that distributes load. I've already told you. It has auto scaling capability that ensures availability and scale. This is an example. For example, your application is deployed in a month from first day of the month, and it needs only one instance on first day, second day, third day, fourth day, till 24th of the day. But on 25th of the month, the number of instances goes up to 6, and it remains so till 29th for 5 days, and again on 30th of the month it goes back to 1. So in traditional solutions you are charged 6 into 30, that number of instances into number of days total. You need to you need to purchase the memory space and computational capability for 6 instances on each day of the month, whether you require or not. This is a waste of money, wastage of resource and money as well. AWS Cloud optimizes this for you. How it does? This is elastic capacity. On day 1 you need one instance. For till 24th you need one, and the days when you need more number of instances, its capacity increases, and you are saving almost 75% of the amount of the physical resources, of the internet connection, and the data price, of electricity, of money, everything. Both are saving. You are saving, AWS is saving. AWS is actually not saving, but they are optimizing their resources, their number of services. They can provide more services from here, and you are charged less. So this is very beneficial to us. This way it is secure, it is very elastic. It has secure access, unique number of users, multi-factor authentication that may include SMS, email, or other biometric devices if you allow that thing. It has private subnets, encrypted data storage, dedicated connection option. It has perfect forward secrecy, security laws, locks, centralized key management. It is cost effective because it follows pay as you go pricing. Whatever your requirement, only on that requirement you need to pay. You don't need to maintain a huge chunk of data, chunk of space every time. It has flexible pricing model. EC2 is feature rich. AWS Marketplace, AMI, Amazon Linux, ecosystem of partners and ISV. It has familiar operating systems. It has third-party integration, and you can perform analytics, deployment, and other enterprise application services on Elastic Cloud. It has operating systems, languages, and libraries based on various languages like Python, Node, Java, and other languages. It has storage options that can be S3 or any other storage options. It has multiple instance types. You get simply 6 type of instances that suits to your application need. You may have a micro, general purpose, compute optimized, storage optimized, GPU optimized, or memory optimized. So what is the difference between them? Let's explore something. For example, if you are building a game application that could be hosted from a web, Facebook game, or any other type of thing, you may need the utilization. Your application requires the utilization of GPU graphics. So you may select the instance type to be GPU optimized. For example, in other case, if you are an advanced explorer, researcher, or some developer on artificial intelligence working on neural networks or deep learning, your application might need the computational capability or CPU usage. So your instance must be opted with compute optimized. Or in the case where you need to store a large number of huge user data, for example, if you are having a blog and you provide registration for username users and need to keep them in the record, or keep the images and other details, and your data is likely to rise very large, so you can have a storage optimized application. Or if your application needs a huge chunk of data on keeping on RAM, the memory optimized. Or otherwise, if you are not yet decided to go with either of them, you can choose general purpose. Or if you need very low amount of storage, GPU or memory optimized thing, then you can go with micro. So friends, we have learned VPC, Elastic Compute, and now we are moving ahead with Elastic Beanstalk. It is another category of compute. Elastic Beanstalk is used to run and manage web applications that can scale up and down with respect to time. So what is Beanstalk? Beanstalk, theoretically speaking, in a definition, it is an orchestration service for deploying infrastructure which orchestrates various AWS services, including EC2, Elastic Compute Cloud, S3, Simple Notification Service, CloudWatch, Auto Scaling, Elastic Load Balancers. It also provides an additional layer of abstraction over bare server and operating system. It comes with a pre-built combination of OS and platform, such as 64-bit Amazon Linux, running Ruby, or Python with pre-configured either Docker, other thing. It supports various languages, programming language that can be Java, .NET, PHP, Node.js, Python, Ruby, Docker. Docker is not a language but container. It can work with different web servers like Apache, Nginx, Fusion Passenger, IIS of Windows. You need to simply upload your code and AWS handles everything from deployment, auto-scaling, capacity provisioning, health monitoring, load balancing, and everything. You just need to deploy and scale your web applications easily. So how it is configured, this is a simple architecture of Beanstalk where host, operating system, language interpreter, application server, and HTTP server is managed by Amazon EC2 or AWS community. You don't need to focus on these things. You just need to focus on your code and they get deployed easily, and it is rest other things are managed by Beanstalk. So what are the benefits of AWS Beanstalk? It is fast and simple to begin with, start with, uh, work with, and complete with. It has a developer productivity mode, and your data or your information cannot outgrow the capacity of Elastic Beanstalk. As your data increases, the capacity increases, and you cannot outgrow it. As per stats, it has not infinite storage, of course, but its storage is very large. You have complete resource control, and the most important and very astonishing thing is that you don't need to pay any charge for using the AWS Beanstalk service. It is free of cost. You only pay for the underlying AWS resources, that could be Elastic Cloud or S3 storage or any other services like Analytics, Kinesis or Cognito and other services. You don't need to pay for auto scaling and other things that is covered with Beanstalk. Beanstalk can simply be integrated with other solutions. For example, this is a toolchain or lifeline. When you first write your code and deploy using libraries, it get connected with Docker image and Docker Hub ports it. Then Elastic Beanstalk takes the Docker run file, Docker configuration file, and your Docker Hub information and data or source code, which is packed with Docker image, and then it leads to development, quality assessment, and staging, or as well as production stages. So it is a component of DevOps process. So keep learning, keep moving ahead. We will move with serverless computing in next video. Now we are moving to Amazon EC2 container services, where we can run and manage Docker containers. That is useful for any DevOps tool chain or when we are working in a team. So what is container service on AWS Cloud? Where in container service we can run Docker containers in EC2 cluster, and that is managed by Amazon. We have API control. We have support images from private Docker repositories. It is compatible with other services and features, security groups, etc. So these are the two types of container services, the Kubernetes or Docker for deployment, for easily package and other thing. You can run any number of Docker containers across a managed cluster of EC2 instance using powerful API and other tools. The multiple number of Docker containers can be managed with the EC2 container service, which is easily managed. Take an example. If you have to supply various package codes to other persons, other teammates of the developer team or testing team, and if you have a lot of teams in the same manner, managing the entire stuff is getting very difficult. EC2 container services provides you flexibility to do those things. You are not required to install cluster management software or purchase and maintain the cluster hardware. The physical hardware is not required on your site. That is managed by Amazon. Or you don't need to match your hardware inventory to your software needs when you use the ECS. Traditionally, when we use our own hardware devices on our own premise, we need to cope with the technology. The technology is ever changing and ever evolving. But with EC2, that is automatically upgraded when it is required, and you don't need to worry about that thing. You simply launch some instances in a cluster, define some tasks, and start them. So some of the advantages or benefits of the EC2 container service is that it has easy cluster management. The cluster is easily managed, and it has high performance as compared to the previous solution, the primitive solution. It has flexible scheduling. It is extensible and portable. The code you are writing or deploying or testing is portable among the developer teams using container services. It has resource efficiency, and it has AWS integration solutions. You can integrate it with multiple solutions available on AWS cloud. That could be Beanstalk, uh, Kinesis, that is a big data analysis solution, or any other solutions like Cognito or other things. It is secure as well. So keep learning, keep moving ahead. We will learn Elastic Beanstalk later in next video. Friends, we have explored various compute services on AWS, Amazon Web Services. We have explored VPC, Virtual Private Cloud, Elastic Compute, Elastic Beanstalk, and now we are moving to with Amazon Lightsail. So what is Lightsail? We will explore it here. Amazon Lightsail is an Amazon cloud service that offers bundles of cloud compute power and memory for new or less experienced cloud users. This is a service targeted mainly for an user who are not experienced about cloud and just want to try it, but does not have enough time to explore these services. The Lightsail provides few of the services or more of the services bundled together in a complete solution manner. It derives compute power from a EC2 instance and repackages it for customers who are new or inexperienced with the cloud. So what does your Lightsail plan include? It includes CPU cores, SSD blocks, solid state drive blocks. That is very beneficial for as you talk about computational capability. It has good networking and data transfer mode. It has a DNS management include, that is a route 53 involved. You have one static IP instance. You have access to AWS services. So Amazon Lightsail is launched on VPS, Virtual Private Server, which are virtual machines with individual operating systems that can be Linux, Windows, or other versions of Linux. That can be Amazon Linux, Red Hat, Fedora, Ubuntu, and other SUSE or other options. But restricted access to physical server resources. You don't have a direct access to physical server resources. A customer can choose from 5 Lightsail plans with the following characteristics. The characteristics are from memory that can range from 512 MB to 8 GB. The processors with 1 or 2 cores, a solid state drive with 20 to 80 GB of storage, and data transfer allows for 1 to 5 terabyte. The prices range from $5 to $80 per month. It is cheap as compared to previous traditional manner of storing or solutions. Lightsail is the easiest way to get started on AWS. You just need to create this Lightsail account, Lightsail application, and everything get deployed on a very rapid fashion without any worry of other services. Later on, you can integrate it with other solutions. It has fully configured server, low predictable price. It can be tailored with API and CLI. We can also build a solution like Word. We can integrate WordPress with Lightsail. WordPress is a popular content management system used to manage blogs where we have multiple users and other things. It is hosted online. It is of course a website. We can launch WordPress with Lightsail within a few clicks. That is fully configured and ready to run. We don't need to write scripts. That is pre-configured. We just need to provide our data and configure things. It is secure, up to date, and optimized for security. It has integrated firewall and port management. It has virtual machines that isolate sites from abuse or attacks. It is simple to manage. It has intuitive console that makes running a VPS virtual private server easily. Virtual private server is a very important thing. For example, a certain entity of the physical server is hacked, but your process is isolated and it is untouched. It has a scalable capacity we can use with larger plans and add additional AWS services as our website grows up or down. We can scale and even integrate with other solutions. So keep learning, keep moving ahead. We will explore more in other categories and we will build a practical solution. Welcome back, friend. We are done with AWS EC2 Elastic Compute Cloud, and now we are moving ahead in other service in the compute category, that is Amazon VPC or Virtual Private Cloud. It is similar to VPN or Virtual Private Network, but it is hosted on cloud, that is isolated cloud resources. So what is VPC? VPC is a provisionally logically isolated. It provisions a logically isolated section of the AWS cloud that may have a multiple resources, given that may have separate IP address or subnets or routing table or security groups or other things. You can control them over the cloud. They are hosted as they are kept in your personal network in your office, but they are hosted on the cloud. If suppose I have 50 members and they have 50 resources and they are residing in globally in 50 other different countries, we can collectively call them as a private cloud, a virtual private cloud. We can collectively call them a virtual private cloud similar to VPN based on certain categories. You can connect your on-premise network also with this via hardware VPN to VPC. You can control if how your instance access the internet. This is the model, how it works. So, within the boundary of AWS cloud, Amazon Web Services cloud, hosted on the internet, here you have your virtual private cloud where you have multiple IPs or domain corresponding to different resources hosted throughout the globe, and they are separate from other AWS clouds. Your cloud is your cloud, that is private, and if you want to keep some segment of your virtual private cloud to be public, you can do so. And you have a third option. If you want to connect your personal VPN connection, if you have, you can do so with Amazon VPC, and both work as a single instance. The only barrier is the authentication barrier between them, and they are isolated and from other cloud resources. So what is more and to getting more into VPC, they are logically isolated section of AWS cloud. It is one of the most used services on AWS VPC. Enterprise customers are able to access the EC2 Elastic Compute Cloud over an IP segment based VPN. Unlike traditional EC2 instances, which are allocated internal and external IP numbers by Amazon, the customers can assign IP numbers of their choice from one or more subnets. You can define different subnets. You can purchase separate IPs that can have any top level domain, assigning it to various resources, and you can build a complete solution with VPC. By giving the user option of selecting which AWS resources are publicly facing and which are not, you can define which resources are available to public on your VPC. For example, if you have an YouTube account and you can upload multiple videos, for example, you have uploaded 10 videos, then you have an option to make some videos to be public or private. You can make all the 10 videos to be public, or none of them to be public, all them to be private, that is not visible to any other user than you. You can set permission to that only few visitors can view your video that subscribes to you, or you may choose to provide link, or you may choose an option like this. You may want to make 4 videos to be private and other 6 videos to be public. The VPC is not different from that thing. It involves the same concept here. Some of your resources may be public, some of the resources may be private. You can do so with VPC. VPC provides more granular control over the security. You have option to select the firewall categories, and you have root access or admin access on your single click. So this was VPC. Later on we will explore more in the compute category. So thanks for now. Here comes Amazon DynamoDB, that is predictable and scalable NoSQL data store or database. You can store a data set or your data in key value format or in document oriented database with Amazon DynamoDB. So now let us explore what is DynamoDB. DynamoDB is a fully managed proprietary NoSQL database service. It is not a relational kind of database. It can be integrated with Hadoop via Elastic MapReduce. The languages frameworks that are supported with DynamoDB to be programmed are Java, Node.js, Go, C Sharp, .NET, Perl, PHP, Python, Ruby, Haskell, and Erlang, or the new form of Erlang programming language, that is Elixir. They are supported on DynamoDB. DynamoDB is fast, consistent performance, single digit millisecond latency, very less latent. As it is document oriented, it is highly scalable and can handle a large number of requests simultaneously. You roughly need zero administration when you go with DynamoDB. So how it works consists of, it basically consists of AWS SDK, that is two types of thing: DynamoDB Web API and DynamoDB Streams Web API. It consists of two fundamental entities, the DynamoDB where data is stored, and DynamoDB streams that are used to call your application or flow in a catch form. So they interact with your application in the fashion your application sends API request or API calls to SDK, DynamoDB Web API, and streams. First, the DynamoDB Web API is called, it returns a request, then DynamoDB Streams is called, and it returns the request, and your operation is continued. Let us test a use case for this. For example, if you want to do some malware analysis, you can implement a solution like this using multiple Amazon services like DynamoDB or AWS Lambda. So how it works? In your DynamoDB, you have two large set of data sets are stored. That is malware catalog and event store, where you store the details of a malwares and events. The first thing that happens in your system is that a threat intel with malware hashes are recognized with threat intelligence script or concepts which are verified or recorded on the malware catalog stored in DynamoDB, which is being upgraded. Then the malware catalog is report the sensors of various devices, report software installation events based on that malware hashes. Then DynamoDB creates a streams of data that triggers Lambda, where your script, serverless script for uh, your applications like push notification and other things are stored. Then Lambda compares against known malware hashes that map a new hash is compared to known hashes, and when it is compared, it publish alert upon match using SNS and sends notification, email, mobile, web app notification, any kind of notification to the uh, assigned responsible authorities. This way you can manage a software, or for example, this is a use case for an antivirus firm that can recognize a new kind of virus or malware. You can build a large number of solutions. This is another use case for DynamoDB. Here we have integrated multiple solutions, that is Amazon IoT, DynamoDB, and API Gateway. We have developed an IoT application where a user triggers when IoT event is triggered, for example, a button click. Then AWS IoT, which integrates your IoT device hosted on internet and triggers an Python script via AWS Lambda. The script uses certain content stored on your DynamoDB database, which can trigger another Python script or any other language script or simple functions via Amazon API Gateway, and your RESTful states can be generated. So this was DynamoDB. It is similar to MongoDB or other NoSQL document-oriented database. You can give it a try. Your data is stored in a JSON format, key value pair. The documents you can also store in CSV format or simple text formats, but your data must be in key value format. You can check out more details and build a solution. So friends, we have explored other services of Amazon. Now we are going to explore Elastic Cache. It is not a database actually, but it is an in-memory cache which is very fast because it is cache memory. The data kept in elastic cache is usually in a high demand and must require a high speed. That data is kept in elastic cache. It is also a middle layer in between the web browser and storage. It improves performance of applications. Speed your applications by bypassing database access and disk storage. Elastic cache is used for high speed data access. For example, if you have created a website where a person is supposed to log in with his credentials and then retrieve all the resources from that database. But if your website requires multiple time of login, then retrieval and verifying all the times from the original database is a tough job. If you can store some of the credentials or hashes in elastic cache, it would be better and easier for you to do so. It supports two types of engines, memory cached and Redis. You can use either of the two. The Redis is very fast, rapid, and it is highly integrated. We would explore it in the coming slides. And memory cached. So how we can integrate build a solution? This is a typical use case for elastic cache. We can integrate other solutions like DynamoDB, AWS Lambda in virtual private cloud, or API gateway. This is a scenario where, for example, a GET session is started, GET request is made from the API gateway or from the web browser, which is passed through the API gateway to a specific function that is stored on AWS Lambda. The Lambda functions could be setup stations function, stream processor function, and list stations function in this case. The first request is sent to setup station function. Then that function is called and some operations on the database DynamoDB, that is NoSQL database, or you can say replace it with RDS or any other form of database. The function, a Lambda function is called, some operations is performed on the database or datasets, retrieved or verified, that could be login or other form of things, which then generates a stream, DynamoDB stream, and triggers another Lambda function, that is the stream processor function, which then triggers elastic cache. It fetches some information from elastic cache which was in the backend fetching from other database or other storage like S3, which can also be directly triggered by another script, that is list stations function. This is a typical scenario that a cloud architect is going to devise. Let's study another scenario. This is suppose as we have learned earlier, you can also host a static website using S3 storage. You just need to upload some files, HTML, CSS or JavaScript files online, and you just generate a file name for index file, and you just click on the link address to that file, and it will open up. So how it could be better work in an integrated environment with using multiple AWS services. So let us see a typical example. We have hosted our website in S3 actually. So this is at the bottom right side, the red one, Amazon S3. This is dynamic content and the above one is static content. For example, if we want to open up our website, a browser made a request from any remote location throughout the world to open this website. He has the URL which is directed to the AWS CloudFront distribution and checks whether this website exists or not. If it exists, it searches to an S3 storage and provides the link and the page available to the web browser directly. Here we made use of two services Amazon CloudFront distribution, and Amazon S3. In S3, HTML, JavaScript, or CSS static content was kept. Another scenario where we want to provide dynamic website, we can use another solution where some of our content is kept in S3, some of our data is kept in DynamoDB or RDS or other form of database, and we have certain scripts that are serverless or Lambda functions that are kept in Lambda. And we have elastic cache where some vital information that are required multiple times used to be kept in elastic cache. So this is an integrated solution where we can employ multiple types of databases as well as storage options as well as Lambda functions with elastic cache. Here, when a browser make a request to open a certain website, it goes to Amazon API gateway, passes through the virtual private cloud where your application resides. It triggers a Lambda function that may call Amazon DynamoDB, fetch some information from DynamoDB, fetch or write some information to or from RDS, Relational Database Service, using any kind of database, MySQL, Postgres, SQL Server, or other things. Fetch or write some information using Amazon Elastic Cache that we are exploring right now, and with some login credentials that may require IAM authentication to Amazon S3. Now we can use Elastic Cache for Redis. So let us explore what is Redis. Redis is an option for Elastic Cache. It has a managed service, use existing clients, pay as you go is available here. It is available in all public AWS region at launch. It is not available at US Secret or US Government Cloud because we can't host a website in anything in that region. That is restricted to some common users. So Redis is not very typical thing where it is a simple solution using Elastic Cache. When you create an instance of Elastic Cache, you have an option to create a Redis. You can use Redis to accelerate your application. It automatically makes use of elastic load balancing, EC2 application instances, app reads, cache. You can use cache memory. It is simply cache for database or any kinds of reach. We can use it in other scenario, the elastic cache. For example, we want to develop an IoT solution using cloud. Here we make use of multiple AWS services. For example, certain event is being triggered by any AWS IoT device, which is authenticated or reflected by AWS IoT service, fetched by that service, recorded by that service, hosted on cloud based on certain domain, and login by that device, which may trigger any AWS Lambda function, Lambda code, the serverless code, which may require access to elastic cache or some data which is fetched from EC2 Elastic Compute Cloud or computed on that behalf and reflected back to Elastic Cache. Elastic Cache then provides the data back to AWS Lambda script, and Lambda script performs certain types of operation. We can devise a data. In another case, this is other use case where our IoT device creates a Lambda request. The Lambda function calls when the data is very hot or very specific, very highly required. We can make use of elastic cache, or if it is not highly required, very hot data, we can use a longer retention and store the information in DynamoDB or RDS. Or when the data is very less useful, or the size of data is very large or quantity is very large, and we could not afford elastic cache in that scenario, or actually does not need that data, we can store in the vault or warehouse, either in Glacier or Amazon S3 using Amazon Kinesis Firehouse. We can also capture data using Redis. This is another use case similar to that thing. We can capture or do analysis work. Big data analysis is a popular term. If we have an information about a site or certain kind of data application, we could do analysis using Amazon Kinesis streams from the data source and store in either of the format. If it is hot data, we can move to Amazon Elastic Cache, either using Redis or without using Redis. If it has longer retention, we may use RDS or DynamoDB, or when it is not useful at all in real time, we can uh, store it at cold vault. So this was Elastic Cache. We can make complex applications or solutions using Elastic Cache. So keep learning, keep moving ahead, keep building a solution. Here comes Amazon RDS or Relational Database Service. We are going to explore it right here. So RDS is Managed Relational Database Services that comes with multiple relational database service options. That is Oracle, Microsoft SQL Server, and other things, other databases. So what is RDS? Basically, it is simple and fast to deploy. It is a relational database where you can create tables, databases, create a schema, run SQL queries, and run other backend scripts like PHP and other scripts that run SQL query. You can store your data, retrieve your data, and do all the operations that you can do with any traditional SQL based database that comes with Amazon RDS. AWS handles patching, backup, and replication. It is compatible with your application. Choose among the available databases. The Amazon has its own database, that is Aurora, and the new one is MariaDB. It is fast, predictable performance. You only pay for what you consume. That means pay as you go. No initialization cost. Amazon Relational Database Service consists of multiple solutions where you can have choice of database engines, managed services, easy to scale and operate, high performance, and high availability. So these are the services or database options that you get: MariaDB, Amazon Aurora, Oracle, Microsoft SQL Server, PostgreSQL, and MySQL. You can also create multiple databases at same time of different vendors and build an integrated solution almost in minutes of time. What you can do with these databases, you can read replicas, customize performance, create automated backups. The backup, you don't need to create replication or shredding, that is automatically done here. You can integrate IAM authentication to drive other developers or testers or your team to access the database services. It is cost effective, highly available, and you can integrate monitoring tools like CloudWatch or other things to monitor the resources and everything that is used. So let us now explore Amazon Redshift, which is another in the database category, but it is not actually a database. It is a columnar relational data warehouse. It is a data warehouse where a large chunk of data, larger than the database, is usually kept and stored. Let me tell you a simple example for those who don't know the difference between database and data warehouse, which information is kept in database and which is kept in data warehouse. You may have booked a railway ticket train ticket, metro ticket, or aeroplane ticket online. So think from the perspective of the airline agency. When somebody or a large number of people book their tickets for a particular flight, suppose let's say British Airways carries over 1000 flights per day from different locations across the world. So for each flight, almost 1000 persons or 500 people, for example 500 people, book their tickets online. They book ticket in advance, usually 1 or 2 months ago. For example, they booked a flight ticket for 22nd October 2018. Till 22nd October, the information of the people who will travel through a flight will be kept in a database. When the data is hugely required, you can perform query, validation, and other forms of data operations. After 22nd of October, when the flight has landed those people, the data is not actually deleted, but it is shifted to a data warehouse. A data which is not being used right now, but can be used in a near future for any sort of thing. For example, if the plane crashes, so there is a problem for insurance claims. So how can the airlines industry verifies who were boarding on the flight? If they have to maintain everything on a database, the database will soon degrade on, because there are 1000 flights every day, and they have to list details of 500 passengers each day. Such a huge challenge to a database. So all the data which is not in current use is stored in the data warehouse. So Redshift is a typical solution. So now let us explore what is Redshift. Redshift is a columnar relational data warehouse. It is massively parallel. It can perform parallel processing. The data that can be stored here is of the scale of petabytes. The charges for your storage is up to $1000 per terabyte per year. So it is cheap as compared to other solutions. You can use existing business intelligence tools like Tableau and other tools along with Redshift. It is based on PostgreSQL, so it is relational and you can perform SQL queries and operations. So this is a simple architecture for Redshift. It has a leader node, the compute node, and everything is mirrored. The leader node manages the compute nodes who perform columnar storage and execute queries in parallel slices, either via S3 or other sort of storage. The leader node performed is based on Postgres, stores metadata about compute nodes. It can communicate with clients using business intelligence tools and other things. It helps coordinate query execution. So this is a simple scenario where the difference between traditional data warehouse and Amazon Redshift. In traditional data warehouse, you require a large number of teams to manage your data warehouse. You need to maintain physical facility, network engineers, database administrators, and other sort of developers. But with Redshift, you don't need to worry about all sort of things. Everything is in cloud and managed by the cloud vendor. You just need to upload your data or download or retrieve or just forget about it data. Redshift worked with existing business intelligence tools. The tools could be Activate, Burst, Jaspersoft, JReport, MicroStrategy, Pervasive, Tableau, and more. They can interact with Amazon Redshift using JDBC or ODBC bridge, ODBC JDBC driver for languages like Java, C, and other. Connect using drivers from PostgreSQL and other things. This is a typical scenario where we can integrate a solution with Redshift and S3. For example, we have currently a corporate data center where our a huge chunk of corporate data is stored in data warehouse, and suddenly our company start feeling that we should migrate our data on the cloud. So how we can do so? We will define the schema conversion tool, establish certain migration agents. Then the migration agents pass our data to Amazon S3 bucket, that is object storage. And after your data is passed to S3 bucket, it is shifted to Redshift, Amazon Redshift, the data warehouse. We have explored various solutions. When we copy or remove our data directly from any outside vendors, outside of warehouses and traditional storage, we firstly actually upload our data to S3 bucket, simple storage service. Then we can copy that data to Redshift or other form of data, which is quite simple and easy to manage. So this is another case how Redshift works. A person can log in with AWS console, check schema conversion tool, perform SQL operations based on SQL client hosted on internet. The internet gateway goes to availability zone for RDS, Redshift, or data migration service. For example, if you are migrating your data from RDS for Oracle or for MySQL or for any other thing, you can migrate your data from RDS to Redshift using database migration service of the Amazon. It simply migrates your data. Or in the reverse process, you can migrate your data from Redshift to RDS or other form of database. AWS Redshift for retrieval and collaboration, we can use it for retrieval and collaboration also, because it is fast, fully managed, petabyte scaled, making it simple and cost effective to efficiently analyze all your data using your existing BI tools. It is simple. You can also generate custom reports, uh, do analysis work using any form of analysis tools available on cloud. This is simple architecture of Redshift spectrum. A person using any business intelligence tool could log in or could enter the could uh, create a request using JDBC or DBC bridge from client application, goes to the leader node. The leader node uh, controls or divide the task to other nodes. The other nodes goes to independent scaling the spectrums. They perform certain tasks, and the task is reflected to S3, and from S3 it is again fetched back and it is done, where we use redshift scaling and independent scaling. We could skip independent scaling stage or perform directly redshift scaling. We can scale up our data. So try creating your own data warehouse solution with Redshift just for fun. Or if you are building an advanced application, you can build a solution based on this. We are done with storage, database, and compute categories, and now we are going to explore the analytics section of Amazon Cloud or AWS. So what are the services that are provided by Amazon for the application area of big data and analytics? For analytics, the first category or first service that is provided by AWS is Amazon Elastic MapReduce or EMR. EMR is Managed Hadoop Framework. It works on Hadoop environment based on MapReduce. It is elastic, scalable. So what is EMR? EMR provides Hadoop SDFS or Spark clusters. Hadoop 1.0 and 2.0 does not contain Spark, and Hadoop 3 contains Spark, and all the preceding services like HDFS, MapReduce, and Yarn. Other services also Pig, Hive, a large number of services, Impala, HBase, which are supported by EMR. You can create a cluster, fully managed, easy to use, on demand, and have spot pricing. It has tight integration with S3, DynamoDB, and Kinesis, along with various other services on Amazon Cloud. So EMR is very useful if you're working on big data and analytics. So how EMR architecture is composed of? It in Hadoop, if you have learned something else sometimes about Hadoop, or you might be an expert on Hadoop, you know what are the name nodes and data nodes, task tracker and job trackers. So simply that architecture is implied here. The EMR architecture consists of master group controls or clusters. It consists of core group nodes, data nodes, and task tracker daemons. The task group can run tasks that can be added and removed. Amazon S3 can be used for data input and output for storage purpose. The master group coordinates the core and task activities and manages cluster state. There are various forms. The task tracker and job tracker. Job tracker keeps track over the jobs, individual jobs. And task tracker is keeps track over a task. Multiple task trackers can be tracked by a single job tracker. Saying so, the parent node is a parent of multiple data nodes. Use multiple EMR instance groups to perform a large number of operations. Master node or slave group, slave node. This is simple architecture. It is nothing different. Similar to SDFS and Yarn, the SDFS name node and Yarn resource manager. This is an use case of EMR, an application for analyzing Kinesis using Amazon EMR. For example, we have to perform an offline analysis and we have certain chunk of data cluster stored in EMR. So how we can do so? The producer gives the Kinesis request. The Kinesis creates an application which is fetching information from S3 and reflected back using by EMR, Elastic MapReduce. And when we can want to build ad hoc or temporary analysis, we can do so by directly processing on via Amazon Kinesis on each instance or each service on EMR, the Hive, Pig, Spark, or MapReduce. We can abstractly analyze each one of them. Many storage layers are we have option of many storage layers to choose from. EMR may store the data in certain formats, either with DynamoDB, RDS, or with Elasticsearch using Amazon Redshift, or you can perform Kinesis, big data analysis using Amazon Kinesis, or simply store your data in S3 buckets. The Hadoop ecosystem can run in Amazon EMR. It is very important thing if you are a big data developer or some passionate person. You can try each service of Hadoop ecosystem from Hive, Spark, MapReduce, SDFS, Drill, Avro, Flume, Art, Cascading, Gradle, HBase, MapR, Accumulo, Tez, Mahout, Phoenix, and wide range of other services in with EMR. This is another use case for highly scalable data loading architecture into Amazon Cloud Search with EMR. We can create a data loading service which is highly scalable. For example, from left side, we have Amazon S3, which contains buckets which are used by load balancer to automatically balance the loads or distribute the loads, which can be processed and called by independent EMR data leader nodes, which can be partitioned on cloud search, and a replicated nodes can be created. Automatic partitioning of Amazon Cloud Search instances can be based on data scalability. You can pump data in parallel and create replications on Amazon Cloud Search using slave nodes. You can handle a large number of requests at the same time, processing a large number of data. It could help you in building or managing websites like Facebook, Twitter, which have a very large traffic. So, how EMR cluster is composed of? It has master and core. You can create clone over it and store data in buckets, which can be inputted and for outputted, which can be fetched in or fetched out, read or route operations from S3 to EMR at any time with very ease. The EMR service have HBase region server or various other services. It is nothing new, but it is just Hadoop. For EMR, you must be somewhat expert on Hadoop. You can integrate various solutions like Hunk with EMR. The Hunk is used to explore, analyze, and visualize data from a central place. It is an utility, uh, and you get a full analytic solution for big data on the cloud. So this was EMR, Elastic MapReduce, for creating a perfect solution with EMR. Keep exploring some big data and Hadoop environment. Hadoop is very large, and this is not the objective of this course. So we have given a brief interview. You can go with any online courses on Hadoop, and if you are an expert, you can directly build your solution by checking out each of the services that are available on Amazon with Elastic MapReduce. So keep learning, keep working, and keep innovating. Thank you. Let us now head towards Amazon Kinesis, that is real-time processing of streaming big data used for analysis purpose. It is a best tool for analyzing real-time data, streaming data like from HDTV, that is high quality and streaming data. That can be email logs, mobile data, or very long data. It has high throughput, elastic, it is easy to use. It can be integrated with Elastic MapReduce, S3 storage, Redshift, DynamoDB, and other integrations. It enables you to build custom applications for analyzing streaming data for any kind of need. That could be website clickstream, the clickstream data. For example, if you have a website and your website is open, if your website generates roughly 500 hits per day or 5 million hits per day, you can track the number of clicks on each instant of your page, any button, the sessions, and the user details, average timeout, average page view, every time kind of that thing in a real time. You can also analyze financial transactions, that could be banking transactions, social media feeds like Twitter handle or Facebook posts, IT log, that could be very large of a number of log files generated from mobile app data or other kind of data, location tracking events from GPS in using any Android application or iOS applications, and also for gaming purpose. For example, if you have an Android game which is hosted on Play Store, and a million users are playing that game, you can keep track of each person at each moment of time. You have a Kinesis client library using which you can build Kinesis applications and use streaming data to power real-time dashboards, generate alerts, implement dynamic pricing, advertising, and more. You can also emit data from Kinesis data streams to other AWS services like Lambda, EMR, Elastic MapReduce, Redshift, S3, and other services. This is a quick demonstration about real-time streaming architecture of Kinesis. The data can be generated from log data, clickstream, smart devices, or the others that I named earlier. That gets ingestion data gets ingested with Amazon Kinesis using put record method. Then the records are retrieved using any Lambda function that can run code once per record based on stored on S3, DynamoDB, or Redshift. How the streams help in sending and reading data from streams. You can send and read data from streams. The sending data could be from AWS SDK, Kinesis Producer Library, Mobile SDK, Log4j, Flume, and other stuff. And the services that consume streaming data from Kinesis can be Lambda functions, Elastic MapReduce, Apache Storm, Apache Spark, and client library, connector library. This is a typical use case for Amazon Kinesis. The first stage, here we configure our input stream and capture streaming data with Kinesis or Kinesis Fire hosts. The next step is to write your SQL queries, run your SQL queries based on that data set. You can perform operations and generate reports. Then you need to configure output stream so you can send process data to analytics tool and create alerts and response in real time. This is simple direction from flow diagram from input to output. Amazon Redshift, you can employ that for storage of your data. Because the data is very large, you may need a warehouse or a database. This is another use case for a recording a form of thing where the camera devices are you securely transfer streaming data to AWS using Kinesis Video Streams SDK. The live data from webcams or other kinds of video data like YouTube data, the Kinesis systems build durable stores, encrypt and indexes that video streams in real time and batch analysis, perform batch analysis based on batch processing and generates output based on machine learning, video processing, media streaming services and other services. You might be using YouTube for a long time, and if you have created a channel and uploaded some video which may contain some popular audio in the background, however the video is not similar to that song, but suddenly after you uploaded your video you may see an alert warning from YouTube side because they blocked your content because that contained privacy content, uh, privacy thing like a song. So may you have wondered how this could happen because YouTube hosts a very large number of videos, far more than the number of people on earth. Millions of videos are produced each day. So how it could keep track over that? It may use certain cloud service similar to Kinesis and perform machine learning operations based on that. It keeps track over the copyrighted content and checks whether that output is this. It does not check entire video, but streams of data following in your thing, in your video. For example, the original song may be 2 minutes long, but you might have used 20 seconds of that song, but still your video is being blocked. This is the purpose of streams. Similarly, we can build another applications like run JavaScript based browser scripts, interact with AWS SDK for JavaScript, perform operations using Kinesis that could be post processing, pass it to Elastic Cloud, the processing part, and store that data in DynamoDB or Redshift or other kinds of database. So this was Kinesis. We can build complex applications using Kinesis and perform data analysis for a wide range of products, including websites, Android applications, or other solutions. So keep learning and keep moving ahead. So friends, welcome back. Now we are going to create a project with a serverless application where we would integrate API gateway to produce query string and run remote serverless application. So the first step is to create a Lambda function. Move to Lambda service and just create a function. We are interested in creating a function from scratch. Provide a name. We have an option for blueprints and serverless application repository. The blueprints come with ready-made codes where you can have a pre-configured template. Just write a name for a new application. I'm providing a name, my simple lambda demo 123. You can write any name. Provide a runtime, for example node. Create a role from existing templates and provide name for the role. Just I'm providing any random role. This role would be generated by IAM, Identity and Access Management, and we need basic simple microservice permission for this to run. Just copy this role name for further future reference. Just hit the create function button. This lambda function would be created. I'm just copying it on notepad. So this is a lambda function homepage. Here we have Amazon CloudWatch logs and Amazon DynamoDB automatically connected, and this is the inline editor where we would write our code. I have already written it earlier, and our code works the similar way. We have learned handler, event, socket, and callback methods, callback object, sorry. And here we have defined a two variable name, min and max, the minimum value and maximum value. And here we are interested in generating a number that could be a random number between 0 to 10, the whole number. Then we would like to print the error or the response using the callback method and display a number. We can work in a strict mode or without a strict mode. Check other configurations. We do not need to configure anything. It is configured by us earlier when we created Lambda function. And you can set timeout for 3 seconds or 4 seconds or anything, whatever you like. And just hit the save button. It will be saved. And then we could test it, and later we would create a API gateway for. So hit the test button, create an event name, for example, provide anything. This is our event template, hello world, the beginner one. You can attach API gateway from here as a trigger later. Friends, we are now going to add a trigger, the API gateway as a trigger, and we need to configure it as below. You can create a new API, provide a name, for example abcd-123 dash Alpha, you can provide any name. Add a deployment stage, for example production, PROD, and keep it open as a security feature. We don't want a user to log in using IAM credentials, and we want to give our users flexibility to write query string directly in our URL. So hit the save button, and this would be saved. So it is saved. You could always delete a trigger, and it is showing some details. We need to go to this URL, the invoke URL one. Just copy this domain, URL, and paste it in any new tab. It might be showing server error because we didn't have defined any permission yet. When we are executing, it is showing output internally, but it is not working with query string. And the output is showing 9. This time it shows 7. This is a random function. It could have a value between 0 to 10. This is 1, and so on. So our Lambda code is working. API gateway has been integrated, and we now need to go to API gateway. Just move to service, or move to API gateway directly. You could type here if you could not find it, or just move to history one, or choose from the below the services. So we need to we can also create an API directly right from here, or we can configure the existing API. For example, I'm creating a new API directly from API gateway. Just provide any name. For example, this is the name for the API gateway, ABCD API Alpha. It could be regional, library description thing. I hit the create API button. It is being created in the region, and now we can access the resources from here: stages, authorizer, gateway response, models, resource policy. And now just move to create resource from actions. Provide a name, for example number. Hit the create resource button. This is required to create a resource for providing a get request or post request with the API gateway. That is the role for API gateway. Now we need to create a method. For example, I'm interested in creating get request, so select the get and hit the check button. So it has been created, the get request. We need to set integration type Lambda, and in the particular region, for example here Oregon region, US West region, just select a region from here, from Lambda, and we need to provide the Lambda function name here. So our Lambda function's name is my simple Lambda demo 123, and the region is US West. Hit the save button. It is adding a permission with this API gateway instance using get request. It is being setting up, and this is all set. So as you can see here, the diagram appears. It is the client, the method request. The request is made from the client. It goes to integration request, and it is processed with Lambda and integrated response and other thing reflected back to client. This is the detailed. You can configure URL path parameters, query string parameters, HTTP headers, body mapping templates, anything from here that is provided. So we are not interested in configuring these things. Just move to actions and hit the deploy API button. So we need to deploy it. Select create a stage. For new stage, we have not created any stage yet. Just provide a name, production for production, and hit the deploy button. The API gateway is now connected with our Lambda function, and we need to invoke this URL, the particular get URL. This is the URL, and we need to just copy this thing and open in a new tab. So our Lambda function is running. As you can see here, it is printing a number, random number from 0 to 10. Again, it is 1, 5, any number in between. It is again showing a random number. Let's zoom it a bit so it would be visible. The current number is 7. I am writing a query string for providing a random number range, and the question mark min equals to 10 and max equals to 100. So it will modify the range from, for example, 0 to 10. It was the earlier range. We could modify this range from 10 to 100 or 1000 or anything, whatever you would like, using the query string. So this is the detail from the production and everything. The no method is defined here. Just hit this tiny button, move to number, and this is the get request, complete detail. So this is the diagram. It was quite messy. Integration request, move to integration request. We now need to add an inline parameter. Scroll down a bit. Path parameter, query string parameter. Just move to body mapping templates. We need to add a mapping template. It would be or type application JSON based application, and we could allow modification of this query string. It won't work until we set this template. So this is the way of setting the template. Just provide anything. In the brackets, we would write the min value and the max value. This is the parameter. We need to define its value, so it could take input from the URL, dollar input dot parameters varums in this thing, and redeploy this API. Select the stage, the production stage, and redeploy it. And we need to just refresh that URL that we have opened earlier for our query string, and this time we could modify our string parameter values. So let the range would be between 10 and 100, and this is our lambda function. We need to modify this thing to take values, parse that value into integer. So add parse int event.min. Using event object that we have learned earlier, the input is provided to the event object, and event object assigns the value to the minimum and maximum uh, variables. Save it, and now just refresh that URL. It would be better. So it is showing upward range 100 to refresh again. It is showing 30, again 76, again refresh 36. It is between the range of 10 to 100, 14, 86. It is again in the range 70, 71. So it's working. Friends, we have learned how to deploy API gateway with AWS Lambda, and here now we are going to create a serverless application with AWS Lambda and DynamoDB. So first we need to create a Lambda function, move to Lambda from the service panel, and we need to create a Lambda function. Here we are going to create a Lambda function that could write an information, a table, write an information, create a row uh, into a table that exists within the DynamoDB. So with Lambda function, we are writing an information on DynamoDB. Our information would be timestamp. So just create a Lambda function, provide a as earlier, provide a name, role name, runtime environment, uh, select a role, select policy template as earlier. So the name is Dynamo role 123 read role. Simple microservice permission is enough, more than enough that we need. Just keeping this role safe. Hit the create function button, and our function is being created. It could take some time. So it is being created, our Lambda function, and here we are interested in providing the Lambda function and add the trigger as DynamoDB in the later part. So what we are going to write here, I have written it earlier. We simply need to create a connection and a connection to DynamoDB using AWS SDK. We can also do this from command line. So we require AWS SDK that we have declared in a constant, and we have created a connection to AWS DynamoDB in the EU West region. Verify the region where you are creating your application. The region for DynamoDB, as well as Lambda function must be the same. The IAM does not need any region. Just provide the handler function and the table name, the date, and other parameters to write that data back to the database, back to the table. So this was the role. We need to simply save this first. We have created Lambda function, and now we are going to create the DynamoDB instance and create a table. Move to service, Go to database section and select DynamoDB. I'm opening a new tab. So this is DynamoDB homepage. It's loading. We need to create a table. Hit the create table button. Provide a name for the table. The table name must be the same that we have provided in our Lambda function. The table name I provided is user entry. So just write the same table name. It is case sensitive, and provide a partition key, primary key. Sorry. I'm selecting it as a date and provide the number. Hit the create button, and our table is being created. So it is loading. The table is being created, and when it is created, it will show the status to active. So it is being active. The ARN, the table name is user entry. The primary key for this is date number. You could add a short key. The table status is active. It is located in this EU West region, and this is Amazon resource name, which is required for further reference. So when we would run our script, it will show our information in the items meaning. It will add a new entry right here. So when we run our Lambda function, it will show nothing as the output as this figure. The execution result will succeed, and you can move to log. And this is the timestamp entry that is selected, that is updated in a table. The Lambda function adds a timestamp in the table, and this value 152645, that is timestamp.